What is the cloud? Let me go ahead and talk about me. First of all, can you see my screen? Let me look at chat. Can you see my screen where it shows my younger face? Excellent. Now it's not showing all of the Zoom controls or anything, is it? It's just showing the decent slide with a halfway decent picture of me. No Zoom. Awesome. Okay, good. So this is me, Erik Gross. I am a senior level software developer. Combination of self-taught and a lot of education, both in high school and the Navy, and all kinds of courses and such ever since then. John, you can see the presenter view where it's talking about who and what I am. I'm on my laptop, so it's not supposed to show that, but sometimes it does. I already know what to say. I'm going to go ahead and close it off. All right, good. So here's me. Oh yeah, and I already mentioned the fact that I was in the Navy, and I'm the co-founder of the Tech Academy. A couple basic rules about the class. We have a class assistant. You will, if you look in chat, you probably see Cheska in there. She's awesome. She monitors the chat, tries to make sure I don't miss any questions. Please be courteous to her and everybody else. I will say I picked the wrong slide for this. I apologize because it references code. There won't be any actual coding today, although the information we're going to be going over, if you are going to move into the technology industry, will be really, really, really vital. Nothing much really happens in coding, in engineering now, without the cloud being involved in some way, okay? It is a good idea to be an distraction-free setting because even though they want through coding, we're going over some technology concepts and hopefully going to be teaching you stuff. And it's always nice to have a distraction-free environment when you're learning. All right, so chat is pretty straightforward. You guys are using it just fine. I am going to try to monitor chat as we go through this, okay? If you have questions, please just let me know in the chat, and Cheska is pretty good about catching them. And there will be a Q&A period as well. All right, so basic agenda, short intro. We're going to have our workshop, not write code. We will have a Q&A. We'll go over some data about our coding boot camps, and there is a free gift for you at the end, so please stick around for that. All right, so I'm going to switch here, and this is going to be fun. Let me go ahead and move some of my stuff out of the way here. I usually have two monitors, and it's always much nicer to have two monitors, but I don't have that with me right now. So I want to go back to the late 90s, early 2000s when we talk about what the cloud is. And I want to kind of set the stage. One of the best things to think with when you're thinking about the cloud is a couple of fundamental terms that we all throw around and aren't always defined really well if you're not in the technology industry. And that is the internet and the web, or to be more nerdy and particular about it, the World Wide Web. And we throw these terms around almost interchangeably. We kind of use them to mean the same thing a lot of the times, but they are, in fact, two utterly separate, distinct things. And as you start moving into the technology industry, it can be pretty helpful to understand the distinction between the two. So let's talk about the internet first. It was developed in the late 60s by a combination of the government and a few universities. And all the internet is a collection of connected computers around the world. Now, there's a bit of nuance to that, but I just want to stop right there and just really hammer that point home. All the internet is just a bunch of connected computers. At this point, I think it'd be almost impossible to calculate the total number of computers. It definitely measures in the billions. It started with four computers at four universities in America in the late 60s, and now it's billions of computers. But that's really all the internet is a bunch of connected computers. Now, we could talk a lot about all the different reasons why you would want to connect computers up. But at the end of the day, computers are there to help people. The purpose of a computer is to take information in, to transform that information in some way, and to send the data on somewhere. That's really all a computer is there for. They're information processing machines, right? So let that one sit there for a minute. The internet is just a bunch of connected computers. But I mentioned nuance, and the nuance is actually really, really important. The other thing that the internet is a set of what we call protocols. Sounds like a fancy thing, but really all it is agreements. And these agreements concern how would you transfer different types of information between all these connected computers. It's not the information itself. A protocol is just, it starts as a written document, but it's just an agreement. And I think one of the best ways to kind of think with this is to kind of think with what are the kinds of information that human beings would want to exchange if we had a worldwide system of connected computers. One of the biggest ones is email. It's one of the easiest things to think with. Email is a type of information. It's got a certain structure, and the structure of information is pretty important in the computing world. I think we can all sort of like even visualize in our minds what the structure of email type of information is. It's got a subject line. It's got a to and a from. You might have multiple tos. You might get kind of detailed and say, well, there's the primary person you're sending it to, and then there's people you're copying it to, and there's even blind copying, you know? But at the end of the day, you've got who is it to, who is it from? You've got a subject line, and you have a body of the email. You might have some attachments. That's a data structure. And so I bring this up because if we're going to consider the idea that the internet is a big old collection of connected computers, along with some protocols for how to exchange different types of information between them, email is a perfect place to start. It is a type of information, and there are, in fact, protocols, rules, agreements on how to send that kind of information back and forth between computers. And we're not going to, list out every single protocol involved, but the one for email is called the Simple Mail Transfer Protocol. That's all it is. And it started out, like I said, it's a written document. And if you really want to, you could look it up online and actually read the document. You would look up SMTP or Simple Mail Transfer Protocol document or documentation, and you could find it out there on the internet, right? So that's all the internet is. It's just a bunch of connected computers and some agreements about how to exchange information of various types between them. So it's the web. Well, the web came along much later. Came along in 1989, actually. So almost 20 years later, actually. And what the web is a collection of linked electronic documents. Now, electronic documents, again, sounds kind of fancy, but we've all made electronic documents. Anytime you pop open a word processor, like Microsoft Word or Google Docs or whatever you use, and make a file, that's an electronic document. When we talk about the web and we say it's this collection of linked electronic documents, what we really mean is, why don't we store some documents on a computer somewhere, one of the computers that's connected and is part of the internet? Why don't we store some documents on there? And these documents, for the most part, are pretty normal documents. They've got some text on them. They might have some images. They might even have videos embedded in them, that kind of thing. But they have one thing in the document which makes them very, very special. And that is that somewhere on that document content, maybe even many locations, some of the content, like one or two words or an image, is special. Because in addition to being the content, like the words or an image or whatever, part of what that content actually contains under the hood is a link to another document. They call them hyperlinks. You probably heard the term. And so that's what makes these documents so special. Like, I kind of like to visualize it like this. Like, you go to a big library, like picture the world's biggest library. And you're a kid, so you're probably interested in dinosaurs. Not that lots of adults aren't interested in dinosaurs either, but let's say you're a kid and you go and pick up a book at the library and it's about dinosaurs in general, just all kinds of dinosaurs. And you start reading through it and you get to the T-Rex, the Tyrannosaurus Rex. And it's got a brief sort of like description of the Tyrannosaurus Rex. And you're like, I'd like to learn a lot more. And what if you could like reach your finger out and touch that picture of a Tyrannosaurus Rex? And there was a connection defined between that picture and another book somewhere in the library. There was actually a very detailed book only about the Tyrannosaurus Rex. And you could touch that picture, and all of a sudden that book that's somewhere in this huge giant library would just float through the air and arrive in your hands, and then you could read it. Now, obviously, we don't live in Harry Potter world, but we kind of do, because that's how the web works. You can write up a document, put some content on it, and then you can define a link on any of that content to some other document that's part of this worldwide web. So that's what the internet and the web are. Again, the internet is just a collection of computers connected together and some protocols about how to transfer various kinds of information between them. And the web is just a big old collection of linked electronic documents. Those documents happen to sit on computers that happen to be part of the internet, but they're not the same thing. Now, again, like I said, in casual conversation, we throw these terms back and forth all the time. Like, where'd you get those shoes? Oh, I bought them on the internet. Now, technically, you bought them on a web page. And the website that you were visiting is on a computer, and that computer happens to be part of the internet. And it's not like you're wrong to say, oh, I bought them on the internet. It's just this. As you move into technology, understanding the exact specific definitions for a lot of the terms you encounter really matters. So, with all that as background, let's look at the cloud. And again, we'll go back to the late 90s, early 2000s, and we just want to think about how were businesses and individuals using computers at that point. And that's where we hit this spot that says early computing and local servers. I want you to just pretend you work for a bookstore. And the bookstore you're in happens to be in Seattle, Washington. There's a reason I'm picking Seattle, okay? But you happen to work at this bookstore and you've got 5,000 books in your bookstore. And you want people to be able to see all the listings of all the books you have. So you take pictures of all the books and you store them on a local computer that's right in your office. And you write up descriptions of all the books and you store that information on that computer right in your office. And then anybody who wants to see all of your books, your inventory, they have to connect to your computer from some other distant computer. And as long as you tell them how to do that, they can do it. That computer that you have all your information on is called a server. And the computers that would like to get that information are called clients. And for many, many, many years, this basic model of a client that reaches out to a server for information or reaches out to a server to have the server do some work for them, this is a really, really common model for decades. But now let's get a little more precise. And let's look at this store that's in Seattle. And of course, I'm talking about Amazon because they played a pivotal role in the beginning of the cloud. In about 2003, Amazon was expanding really, really rapidly. And they moved way beyond books and were doing a lot of retail business. Another thing was happening in those early 2000s is that, for those of you who weren't around then, internet businesses were getting really, really big, really fast in the late 90s and early 2000s. And then lots of money was being poured into it from lots of companies, and new internet-based businesses would pop up left, right, and center. And then in about 2002, the bottom fell out of that rapid, crazy, insane expansion. That period was called the dot-com bubble. Some of you may have heard of it. Why do we care about that in relation to this thing called the cloud? Well, Amazon at the time had thousands or maybe even tens of thousands of computers that it had purchased and they were using them as servers. And of course, when you buy a computer for a business purpose, you want it to be able to pay for itself by facilitating lots of sales or whatever it is that you're using it for. But we're talking about a retail company. They wanted to produce a lot of sales. And when sales started dropping, all of a sudden they had these thousands of computers that weren't very busy at all. They were installed in big, giant buildings. They had really, really expensive cooling systems because computers generate lots of heat when they run. And they were not making the company any money. In fact, they were at one point about 30 to 60 days from going out of business, and they couldn't raise any more money. And one or more brilliant engineers at Amazon had a really, really bright, creative, weird idea. It was weird at the time. They basically said to Jeff Bezos, hey, we've got these several thousand computers that we're not using, which stinks. But what if we could let other companies use them on like a per hour basis? What if we could rent those computers? What if they could install the software that that company, that our customer, a different kind of customer, what if they could install software that they need and they could use it, but we'd only charge them for the time period where their program was actually being used for meaningful work. And so they had to set up a lot of like infrastructure to make that happen, but they did and started marketing this, not knowing what would happen. And what happened was it exploded. And that was the beginning of a division of Amazon called Amazon Web Services, AWS, which you probably all have heard of. And while there were a lot of other players involved, the story I'm relating here is typical of what was happening at that period. Lots of companies, either through poor luck or on purpose, ended up having a huge inventory of available computers, and they weren't being used all the time. So they decided to basically rent their computers out. And like I said, they had to set up infrastructure for it. They had to set up programs that would keep track of when one of these computers was being used and by what client and for how long of a period, and they had to set up billing for it and all this kind of stuff. But they did that, and it worked. It worked very, very, very well. Which leads us to this thing you see about the cloud. I've seen it on T-shirts. It says there's no such thing as the cloud. There's just somebody else's computer. And that's one of the central things I want to just set right at the front of this workshop, is that's really actually all the cloud is. You need some computers to do some work. Now, you could buy all those computers and install them locally. Like you could literally build a big warehouse with lots of really good air conditioning and put all your computers in there. But that's an expensive proposition. Why not rent those computers for only the time period you want? So those are some of the key milestones. So flash forward over the next several years, what kind of uses did we find for the cloud? Well, we're going to first talk about consumer uses. And we're going to shift into how do we use it in technology? You can see here 3 everyday examples. We already talked about email. We talked about streaming, and we'll talk about photo storage, right? So let's talk about streaming. Let's say you are the American company Netflix, which again, we've all heard of. And you're trying to get this really weird business model off the ground. Now, Netflix had a weird business model to begin with. Some of you may not know that when they started, the way Netflix would work is you'd go to their website and you'd say, I want to watch the movie Band of Brothers with Tom Hanks in it. And you would order it and they would send you the CD to your house, and you'd have it for a week and you'd watch the movie, and then you'd send it back, and then they'd send you another CD. That's how they started. And people laughed at them when they came up with this business model, but they didn't last very long because Netflix made a lot of money. Well, they were laughing again in the early 2000s when Netflix said, you know, instead of like sending this physical media back and forth, we're going to make it so people can come to our website and give us a little bit of money every month, and we will just send that content right to their client, right to their computer. And like I said, people laughed. But obviously they're not laughing, and Netflix is pretty awesome, right? Let's think about the cloud, though. Let's say it's the beginning of this Netflix business. And they know that there's certain time periods throughout the day when lots and lots of people are watching their content or are likely to watch their content. But there's other time periods where they're not that likely. Let's say it's just an American phenomenon. Now, of course, it's worldwide. But think about those early years. You might have a few people watching movies, throughout the early part of the day. Starting with the afternoon into the evening, you get massive load, massive requests to stream movies. And then late at night and into the early morning, probably not much at all. Now, do you, Netflix, want to go buy the thousands upon tens of thousands of computers that are necessary to serve up that content, knowing that about 40% of the day, they're not going to do anything, but you're paying for them. You're paying for the computer itself, which is a capital expense, but you're also paying for cooling for it, and it's not really doing anything. No, they're not going to do that. So they went to these early companies involved in this weird thing called the cloud and said, hey, we'd like to come on as customers because we can pay you only when we're actually having clients, which is a pretty neat business model, right? So this is how early examples of using the cloud for consumer products worked. I want to move on to a little bit of an illustration of where we kind of sit now with the cloud. First of all, like I said, it's just someone else's computer. So when you see the symbol of a cloud here, just think about hundreds or thousands or hundreds of thousands of computers all sitting there ready to be used in tiny incremental minutes or sometimes portions of a minute by companies that would like to use that computing power. And that's really what, like I said, the cloud is. So if you look at the office for productivity, you might connect to this cloud with a variety of devices. Obviously, there's your desktops, right? Your laptops, mobile devices. Same thing with your home usage. You might have a laptop. Some people still have desktops. I do. Of course, mobile devices. And then the cloud computers are going to store a bunch of information on this data center. And of course, the data centers need to be accessed. Again, it's a relatively simplified diagram, but it represents the truth of how the cloud works. The big thing I want you to take away from all of this is if we accept the idea that the internet is just a big old collection of connected computers, why not take a big percentage of those computers and form a business around making those computers available on a time basis? And that's really the essence of what the cloud is. But it's become so much more when we look at not consumer uses, but developer uses. And we're going to talk about that a little bit too. I do want to explain one little symbol you're going to see several times on here, which is this key. And this just represents security. More precisely, it represents a really central concept in computing, which is how do you control access to a computer? And why would you want to? And there's a lot we could say about that. People who go through our boot camp, which is the cybersecurity boot camp, learn all about that in great detail. But we've all dealt with this many times a day as we have to put in usernames and passwords. The central idea here is that anytime one computer can connect to another to either get information or have that other computer do work for them, it's a pretty smart thing to control whether or not the connecting computer is even allowed to do that. And that's all these keys and locks symbolize, is you can have this giant collection of computers, you better have some sort of what's called authentication mechanism. Is the computer that's trying to connect to another computer, is it being used by the person that's actually allowed to gain access? That's authentication. Now, as a consumer, we just know there's a bit of a pain in the butt because we have to put in passwords all the time and everything. But as a developer, this stuff really matters to you. And regardless of your specialty, even if it isn't cybersecurity, it's a central part of the way to think as you put together programs. It's fine to create a program that provides a bunch of really cool functionality, but who exactly is allowed to use it? How do you verify that the person trying to use it is the right person to? So this is central to the cloud. Now, let's talk about key features of the cloud, okay? I really want to talk in a bit of detail about that very first thing there that says scalability. And again, one of the best ways to kind of relate this concept is to go back in time to those early parts of the 2000s. If you got a business, let's say, that's taking off, right? Let's say, again, this Netflix thing, it took off pretty rapidly. As you're busy signing up users, that means that more and more people are wanting to watch Band of Brothers or whatever movie. I have no idea why I picked Band of Brothers. Okay. More and more people are wanting to watch. Yeah, they would basically want to consume information, and that information is on computers. Well, if you've only got one computer, picture it this way. Let's bring it all the way down to like the barest minimum. What if there's one computer and it has a copy of Band of Brothers on it, and you have one person connected to it wanting to watch it? That computer probably can handle that pretty well. It might even handle two at once, or frankly, realistically, it could probably handle 100 people at once if it was a decent, powerful computer, and it would be streaming out that content to 100 people at once. Then all of a sudden we add another 100 customers. And this is where scale comes in. With the cloud, it's relatively easy to make a copy of that computer onto another one. And you can even do it automatically. It gets configured to automatically happen when you have a lot more usage, a lot more demands on one computer. So much demand that the computer won't be able to perform very well. Don't overtax that one computer. Just copy everything on it onto another computer and have it start handling some of the workload. Now, this has tremendous ramifications for business, but also for you as a developer. What it means is you can design a program that is capable of conceivably handling a huge number of concurrent users, and you don't have to worry about whether or not your company actually happens to have a tremendous ton of computers in its own inventory. It doesn't matter. You can design it for the most ideal situation. It wasn't always that way. You would very often have to design programs knowing that computers were super expensive. You had to be very careful about exactly how efficient every single operation you made the computer do was, because this was a real factor. But with the cloud, you can scale very rapidly, like in milliseconds sometimes. You can add on more capability. And then there's reliability. Let's say we're back in the day when you owned your own computers and the air conditioning goes out in the server room. This is a very real thing. I'm not being kind of silly about this. This would happen. Let me tell you, a room filled with 500 computers and they're all humming away working heats up very, very fast and can heat up very rapidly if you don't have cooling, so quickly and so badly that the computers themselves will shut down or actually get damaged. Well, if you've got access to a giant network of computers owned by one of these big cloud companies, you never have to worry about that. Those companies take care of it for you. They will have systems behind the scenes, make sure that if something happens to one big giant collection of computers physically somewhere in the world that they own, like a bad weather scenario or a natural disaster, they've got systems behind the scenes that will shift all of your resources that were in one set of computers onto a completely different one in a whole different geographical location that is safe. And so the reliability factor is huge. And finally, there's security. If you owned 500 computers and they were in your server room, and there was a vulnerability on those 500 computers, you, as someone involved in the technology part of the company, would probably have to go in and individually update every single one of those 500 computers to make sure that they were protected. Well, flip it around. That responsibility is now on the cloud provider, like an Amazon Web Services or a few more that we'll mention, okay? So the security is actually stronger and easier to maintain. Those are some key features of the cloud. So we talked about some relatively simplistic uses for the cloud, but now we're getting into areas that are a little more nuanced and frankly, a little more developer or computer programmer centric. The first one is this little acronym here, SaaS. I'm going to look at chat. Can anybody tell me what SaaS stands for? And Joe, yes, scalability in cloud means it scales up. Can anybody tell me what SaaS stands for? Good job, Joey. Software as a service. Now, it's been so long that we've operated in this world, some of you may not remember what it was like before. So I'm going to give a picture of what it was like before. I worked for a financial services company about 15 years ago. And they had a really interesting piece of financial software that served the auto industry. And it was capable of connecting up to lots of different loan providers, banks, equipment providers, and all that kind of stuff. And if you wanted to buy this software from them, here's how it would work. You would send them money, and they would send you a big box that had several CDs in it. And on that CD was your program. You would install that program on one computer at your car dealership. That was where the program lived. And if you wanted to use the program, you had to go over to that computer, start up that program, and use it. And what if the company I was working for had upgrades or bug fixes it needed to send out? They would send out a CD to all their customers. Here's the latest version, or here's some vital bug fixes. Take this CD, put it in your computer, click on the little thing that says install, and the program that they have on their computer would get fixed or upgraded or whatever it was. That was how software was done for a long time. One of the best ways to kind of illustrate the shift in software as a service is to think about what it was like back in the day to use Microsoft Office products, because they are ubiquitous. They're everywhere. They're super popular. This is how it worked. The situation I just described is how it worked when you wanted to buy Microsoft Office products for a long time. They would send you a box and it had a bunch of CDs in it, and on it was, Microsoft Word and Microsoft Excel and whatever other programs you bought, and you install them on your computer and your computer alone. And they shifted to a software as a service model. They said, wait a minute, why don't we take this program, Microsoft Word, and we'll install it on a bunch of computers that we own. And then from your office, you will, over the internet, connect to that program. We can create millions of copies of Microsoft Office all running at the same time because we own millions of computers. And our customers no longer have to have it installed on their own computer. They can connect over the internet to our computer. They're providing software as a service rather than software as a commodity, like a physical piece of, a device that you have to install on one computer. That's what software as a service is. And again, I told you that story about what it was like back in the day because most of the things that we all use now are a software as a service model. Many of you are using Zoom as a software as a service model. Now, you can install a desktop version of Zoom. It lives right on your laptop or your desktop, right? But many of you can also just go to a website, the Zoom website, connect up to one of our meetings, and what you're really using is that program called Zoom on a different computer. It's not even on your computer. It's on a computer owned by the company Zoom. And frankly, they probably don't even own the computer. They are renting that computer from one of the cloud providers. So that's the software as a service model. And you will build programs like this all the time as you move into technology. You'll build a program that isn't going to be installed just on the end user's single computer. No, the program you make will live on a computer. Sorry, the program you make will live on a computer out in the cloud. And your users, your company's customers, will connect to that computer over the internet and use the program that you built. That's a software as a service. Then there's platform as a service. A platform is a full-featured environment to do a specific type of work. A real good example here is the company Salesforce. Tell me yes or no in chat, have you ever heard of Salesforce? A no, a no, a yes, a no. All right, so I'm going to show you Salesforce. Talk about what they are. No, I don't want dial pad. I didn't click on that, or if I did, I didn't mean to. Oh, no, that I did, and I didn't want to. Let me go down. There it is. Okay. Salesforce. The customer company. Okay. Salesforce started as just a customer relationship management software. Okay. But look, you can have all the marketing activity of your company in one place, all the sales activity, all the service activity, all in one single, it says it's an app. This is actually a platform. And what I mean by that is it serves both the consumer, like the client, the customers, enterprise companies. They can have all of their sales, service, and marketing work done in one place. But they've grown so big and added such cool functionality that you can be a programmer and build custom functionality into Salesforce. It's a full platform. And platform is one of those words in technology that doesn't have a super strict definition, but it's a fully featured environment for doing a specific type of work. Here, that work is providing marketing, sales, and service functionality and creating custom programming around those tasks. That's a platform. Salesforce doesn't own any of their own computers. And when you use Salesforce, you don't have to install it on your computer. You do what I just did. You connect to their website. And behind the scenes, there's millions of computers all running the Salesforce programs, and you're accessing those computers when you use Salesforce. So that's a platform as a service. And finally, this is where we're really going to get into the cloud and its value to you as a developer. Can anybody tell me what IaaS stands for? Any guesses? Joey's exactly right. Infrastructure as a service. So I want to define what infrastructure is. And this is a weird definition. It's not actually correct, but it's the best way to illustrate it, and then I'll define it. Infrastructure is everything that is not your computer program. Now let me clarify that. You write a computer program, but your computer program needs a lot of things in order to be able to run and do its job. First, it needs to be installed on a computer that has an operating system. The operating system is that underlying master program that takes care of a bunch of underneath the hood things for a computer to be able to do any meaningful work. The main operating systems in the world are Windows, Linux, and Mac OS. There's lots of other operating systems, but that's just an example. An operating system is not your program, but you literally can't have a program work without an operating system. So that's some infrastructure. Also, infrastructure. Your computer program almost assuredly has to communicate with other programs in order to do its job. It probably has to reach out to other computers that have stored information on them. It's got to send information back and forth. Again, that's not your program, but it's a vital need The physical hardware and specialized programs that allow that to happen are called networking hardware and software. And I just, again, want to stress, that's not your program, but your program needs things like that in order to be able to do its job. And there are a few other areas involving data storage and that sort of stuff. The point is, there's a lot of things called infrastructure, and they really are, quote unquote, everything besides your program. Now, in the past, before the advent of the cloud, you would be responsible, or personnel in your company would be responsible for configuring and managing all of those things. They'd have to set up networking actual hardware, like the cables and everything, and the software, specialized programs that manage sending communication back and forth between computers. They would be responsible for that, sometimes at great expense. There'd be people responsible for making sure that all the computers that you bought had operating systems on them, and that the operating systems were continually upgraded as the creators added new features or issued bug fixes, right? So the cloud providers, these companies that own millions upon millions of computers and rent them out to people, said, hey, why don't we put together a bunch of underneath the hood offerings that will handle all that for people? If they need networking, we have a service that they can just pay for that their program can hook into, and suddenly it has networking. It's got the ability to send and receive information back and forth between other computers. And you as the developer don't even need to worry about that too much. You seem to learn how to use it. This is infrastructure as a service. And this is where a lot of your work as a modern software developer will take place. Even if you're not building it, building that infrastructure or configuring it, you're going to need to use it for your computer program that you spent so much time and effort creating to work properly. But increasingly, software developers do need to learn how to set these infrastructure things up out in the cloud, how to make use of them most efficiently at the least possible expense. And so these are some of the three things you see here: software as a service, platform as a service, and infrastructure as a service are basically, they're moving beyond just, hey, you want to rent our computers? And now the cloud providers are going, hey, you can rent our computers, but you can also rent these really cool things we've added on top of the computers. We've built a bunch of things that make it so you can drop your software out here and your software will just live on our computers all the time, and you can charge people for it. That's software as a service. We've invented these huge platforms that take care of everything. You come in and do special functionality and programming. We've taken care of all these infrastructure things, and you can just pay us for them and use them. And what happens is that you as the programmer get to spend more of your time solving the really difficult problems that you were hired to solve. You were hired to write computer programs to solve difficult problems for the business that brought you on. And when you need to spend a lot less time figuring out where exactly am I going to install my program and how is my program going to communicate with other systems and all these things, it's a good thing for you. You can solve even more difficult problems because you can bring a lot more of your attention to bear on those problems, which leads us kind of into benefits of the cloud. There is a big cost savings, and I hope at this point that's become obvious when we talked about those earlier examples from the beginning of this, cloud development in the early 2000s. You're not going to pay for a computer that isn't busy. You're going to pay for the computer when it's being used. And if you manage it properly, you can save a lot of money using the cloud. Also, all of the things that you as a team are working on are not stuck on one computer. They're stuck on a computer out in the cloud that's very reliable and that people can access from anywhere in the world. So collaboration and accessibility become much, much greater with the cloud. When updates are needed to any part of the system, they can happen automatically. They can be set to trigger whenever they're needed. And it makes it a lot easier on you and your whole information technology team, your whole IT team, to manage your collection of programs and databases and networking software, all the needed updates happen to those behind the scenes automatically for you from the cloud providers. And you gain a lot of flexibility. If you're a startup and you're not quite sure what kind of demand you're going to get for your service right at the beginning, you can be very flexible. You can put an offering, put a service out there and promote it and see how well it takes off. And if it isn't quite addressing the exact need that you thought was there in the market, you can shift really quickly and change your program pretty quickly. And you're not having to buy a bunch of new computers or create a whole bunch of new infrastructure. That stuff can be switched out super easily. And so you can be very flexible and efficient in what you do. We've kind of already talked about security and privacy, but I do want to talk about some of the dangers here. As much as I said how cool it is that one of the key features of the cloud is security, because the people that provide all these cloud systems, like I'll name them now, Amazon Web Services or AWS, Azure from Microsoft is one of the other big cloud providers. Azure, and then Google Cloud Platform, obviously from Google. IBM Cloud is big, and then there's Oracle Cloud. And those are just huge technology companies. Those are the real big players, right? They do, in fact, have a lot of personnel that work to keep all of their systems secure, but you are trusting them to do so. And if you paid attention to the news at all over the last 2 years, you know that sometimes they fail. There's been a couple of extremely high-profile security incidents with some of these big cloud providers over the last few years, which basically brought this danger into sharp relief. And so the security and privacy of the information on these computers that you're no longer in full control over, you literally don't know where the computer is that your programs and your data are on. You do have some concerns about security and privacy, right? Now, as an engineer, you will learn how to address these. You can even specialize it, like in that kind of thing, like I said on, say, our cybersecurity bootcamp. But you have to always be thinking about it. You are no longer using computers that you and your company are fully in control of. And when you abdicate that responsibility, you gain a lot of advantages, but you increase some of that risk, and so you need to be concerned with that, okay? We've talked about a lot of real-world applications. One of the things I do want to address here is the emerging technologies thing, specifically AI. Now, give me an answer in chat, yes or no. Have you used some of these modern cool AI tools that have come out over the last 2 years? Yes or no? Like a ChatGPT or Llama or what the other one is from, there's a few of them. Okay, some yeses, a lot of yeses, a few nos. Okay, well, we've done a few presentations on AI, so I'm not going to give a big old dissertation on that. But I will say this. For these modern conversational chat services to work, they need millions of computers able to serve a global audience, and they need to be able to scale. Sometimes the demand on them is super heavy, and sometimes it drops. There's fluctuations throughout any given day or week or month. And so the cloud, obviously, is where you're going to want to put those. But that means any interaction you have with those AIs is out on the cloud, and as we've just talked about, may not be secure and private as much as you might want. And so this leads me to one of the principal things I want you to take away. The cloud is not always the solution. And we could think of many different instances where you really wouldn't want your data, your information to be out there on the public cloud. National security concerns obviously will come to mind for the different governments around the world, but they can be business concerns. You might have extremely important business data that you don't want to have out on a computer that you can't even be in control of. And so I don't know that we'll ever move 100% to the cloud with every single computing type of computing work that we do. And so as an engineer, you'll start to develop more and more like understanding of when you do and don't want to use the cloud. But most most of the time, most of the work you'll do will be built in the cloud, deployed in the cloud, maintained in the cloud. It'll live there all the time. Okay. So finally, let's talk about how to get started. And I'm going to talk about this now as a developer, if you're considering moving into technology. The big takeaway here is don't worry too much about the cloud right now and just learn the fundamentals of programming, because they apply no matter where your program lives. If the program lives in your business's own data centers, they're maybe even down the hall or down the block, you're still writing the same program as you would if it was being deployed out in the cloud. And so the fundamentals of how do computers work under the hood? What are the fundamental elements of any computer program? What are the data structures you're going to work with? What's the general pattern and process of how software is made? What are the basic technologies of the web? What are databases and how do they work? How do you practice version control or keeping track of the history of all the parts of a big project? All these fundamentals need to be learned. And then you start looking at, okay, I can make software, I can work with databases, I can work as part of a team. Now, can I do those same things either on local computers or can I do them out in the cloud? So don't jump into, oh man, I need to get a cloud certification as the very first thing. Learn those fundamentals. It's vital. But when you get to that point, how do you get started? Well, my recommendation is to just pick one of the big three: Google Cloud Platform, Microsoft Azure, or Amazon's AWS, and just start doing simple basic tutorials. Don't start there, like I said. Just learn the fundamentals of your job, and then start to look at the cloud providers and pick one of them. Don't try to learn all three at once. And the simplest thing you can do is, okay, how do I take a program that I have running on my computer, and how do I do the same thing out in the cloud? How do I get that program to actually be living out in the cloud? And how can I connect to my program now from a remote computer? Instead of running it on my computer, how can I have that program out on a computer in the cloud? And how can I even access it? And there's lots and lots of tutorials for all three of those big cloud providers that will lead you through that process. Now, on our boot camps, you learn the fundamentals of this, period, at the right stage of your learning process. But if you're intrigued at all by this whole concept of the cloud, again, those two big takeaways: one, it's not the answer to everything. And two, you don't get started there with your learning journey. Learn the fundamentals of computer programming and the basic skills you're going to need to operate as part of a team as a software developer, and then start looking into the cloud. So I hope that kind of puts it in perspective. Now, I've been watching chat decently and answered a couple of questions, but I want to be able to give people plenty of opportunity to get questions answered. So give me just a moment here. Let me get some stuff out of the way. All right. So before we go all that, questions. Anybody have questions about the cloud or anything about technology or computing? I'm here. I'm willing to answer anything you want to talk about before we move on. Oh, Tanya asked, which cloud service is the most used today? It's probably AWS with Azure close behind. I've used all of them, all the big ones. I started because I was a Microsoft developer, being very Azure centric, but AWS's offerings are phenomenal. I will use Google Cloud Platform if I'm forced to at gunpoint, but that's just a personal preference. But yeah, probably AWS is the most popular. We've got a question: can the cloud get hacked? 100%. It absolutely can, right? Now they have very bright people working at these cloud companies, and they in general do a really, really good job. But the only secure computer is one that's not connected to anything at all and is turned off. End of story. There's no such thing as a fully secure computer that's running. There's ways to get into any computer system. Okay. Now that said, in general, the engineers at the cloud companies do a pretty good job. but the cloud absolutely can get hacked. Because think about this. Every single one of those computers that one of those companies owns is connected to the internet. It's part of this big giant, and that's why I covered that at the very beginning of this workshop. The internet is a giant collection of connected computers. Now you can put in lots of safeguards to try to prevent unauthorized people from connecting to any one individual computer in this massive network, but you're never going to be able to account for every single possibility. Also, most successful hacking attempts aren't a pure technological attack. They involve what we call social engineering. They involve fooling or tricking or getting the collaboration of someone who has access to the computer you want to connect to. And through whatever means, getting them to get you in the door, right? So yeah, the answer is the cloud can be hacked. It doesn't happen often, but when it happens, because we started to rely on it so much in enterprise organizations around the world, it can have massive impact. John says, is there any alternative of learning the cloud if you're a self-taught developer other than trying AWS or Azure certification courses? Just like if you're a self-taught dev, you can try learning languages through making your own projects. There's a few different things that approach rather than jumping right into one of the certification courses. Although I will say they're both Azure and AWS, their training that you can access generally for free. It's pretty good. If you're already an experienced developer, it's pretty good. If you're starting without that, and that's why I talked about the fundamentals earlier. Without all that fundamental knowledge, you can be pretty lost pretty quick, okay? But alternatives to that, really you're looking at a few decent providers on YouTube that do a decent job. And obviously we do a phenomenal job in our boot camps when you get to the right portion in your program of learning the cloud and how to actually utilize it, right? It's relatively Azure centric because again, we started out as a Microsoft shop, but you can transfer those skills to any of the cloud platforms pretty easily. Hope that helped. Rachel says, on TikTok, I heard of a job called cloud engineer. Just curious if you knew anything about what they do. Are they software engineers? They do a lot of coding. They are. A cloud engineer is really just an engineer that does most of the work in a cloud-centered point of view. So from the beginning, when they create a computer program, they're intending from minute one that that program live out on the cloud. If it needs any resources like a database server, that database server is going to be spun up in the cloud. They very quickly learn about how to configure the infrastructure, everything that isn't their program out in the cloud, instead of the opposite of is what's called on premises. That means the computers that you and your company own, right? So a cloud engineer is just a software developer that's very comfortable in that cloud environment, utilizing the cloud providers, using their resources, setting up security and networking and all these things that your program needs in a cloud environment. But at the end of the day, yeah, they're just software engineers and they do a lot of coding. That's a good question, Rachel. All right, got time for one more question before we move on. Oh, good. Before landing a job in IT, this is Joey. Oh wait, there's a bunch. Let me see. I may have had more than one question here, and I don't want to I think I was starting reading that halfway through. Give me just a moment. Expand my chat window here. If I can learn how to operate my trackpad. So yeah, I started in IT with no experience and still learning. Working in help desk is helping me enormously learn every day. Before landing a job in IT, I was finishing my bachelor's in applied management, going back to finish my bachelor's in applied management this fall. Also working on completing my CompTIA A+. CompTIA is a training certification organization. A+, that's a hardware and networking certification. Am I right, Joey? Okay. Do you have any advice or recommendations on where I am at my career and working towards constantly studying each day? Yeah, I'll say this. I'm kind of biased because I've been a software developer my whole life and not in the physical hardware and networking thing. But the data is pretty clear. You just make a lot more money as a software engineer than any comparable role in hardware. You just make a lot more money. That said, the fact that you even have an interest and any degree of training in some of that hardware and networking stuff is a tremendous advantage for you as an engineer. Many engineers do not know much about that at all. So my advice to you would be to just full on decide, I'm going to be a computer programmer. However you do it, whether it's self-taught, whether you look at one of our boot camps, whether you go to college or whatever, become a computer programmer, but don't lose sight of the fact that you have at least some interest and already some training in the networking, security, hardware end of things. It's, like I said, a tremendous advantage to you as an engineer. It'll open up a wider array of jobs for you. But if you go straight to just working in that hardware area, you're not going to make as much money. Okay. I hope that helps. There's a lot more we can talk about that. You might want to book a call with one of our admissions folks. They can give you a lot more background on that. Yeah. Okay. Mike has a great question. Thank you. He says, when I save an Excel sheet to a local drive, I'll get a pop-up asking if I want to save my data to the cloud. If I say yes, where does it go? Will a version be saved to my local drive, or will it all go to the cloud? I assume it's the Microsoft cloud. Will I need a cloud account? This is a great question. There's this sort of hybrid way you can work. And it isn't just Microsoft that does this. There's several other providers that do things like this, where you're doing a bunch of productivity work on your computer, but where do you store the stuff? Are you store it on your local hard drive, or are you put it out on the cloud? Now, the advantage of being on the cloud is you can access that data from anywhere. If you're not at your computer, but you're halfway around the world and you've got your iPad or whatever, you can log in and you can access your data and edit it, okay? But to specifically answer your question, he says, if I say yes to saving to the cloud, where does it go? You don't know. You don't know. And what I mean by that is it will be saved on a computer owned by that cloud provider. In this case, yes, the Microsoft Cloud, Azure. They own millions upon millions of computers, and somewhere on one of those computers will be stored your file. Now, from a certain point of view, it doesn't matter where it is because you can access it anytime you have an internet connection. But that's the danger. What if you don't have an internet connection? Now, to answer the second part of that, will a version be saved on my local drive, or will it all go to the cloud? That's a thing you can often configure. And I love that you bring this up, because guess what? When you move into technology and you are part of a programming team making computer programs, you're going to have to make these decisions. What is the user experience like? Are we going to be a pure cloud-hosted information program, or do users have an option to store their information locally? If we do, how do we handle it if they are, using really, really old computers with not a lot of space? We've got to provide for the fact that there might not be enough room. If we're saving to the cloud, we never worry about whether there's enough room to store their information, because we have essentially unlimited storage out in the cloud. So great question. The answer depends on whatever program you're using, but these are the exact kinds of questions that you and your team will have to talk about when you move into being a technology worker. That was great. And again, the answer to, will I need a cloud account? It totally depends on who's providing that software and whether they've provided you with their own cloud account or whatever that you can use. That was a good question, Mike. I really like that. All right, let's move on a bit and talk about who and what we are. Okay, the Tech Academy. We are Coding Bootcamp, founded in 2014. We have, self-paced online programs that prepare you for a technology career, by having a well-rounded toolkit. We focus on skills that people need to get hired right away, because you can get through a bootcamp in like 3 to 6 months and become an entry-level technology worker, and you need to know what are people actually hiring for out there. Around the country, at least in America, the average boot camp price is around $13,500. We're well below the national average. We have boot camps that start as low as $59.80, right? And I'm going to pull up our, I don't know if I have it here. I apologize. Our mission statement, I actually know it by heart, right? Our mission is to graduate entry-level technology workers who excel in the basics of their field and have successful careers in technology, and who exceed the expectations of their clients and raise industry standards. Like, our job, we're here to help people get into tech. That's what we do, okay? So that's the Tech Academy. Now, let's end with a couple of questions. Well, a couple more details. we talked about different programs. We've got 12 different certification programs. You can see them right here: artificial intelligence, mobile app developer, Python, cybersecurity, which I've talked about a lot tonight, right? C#, .NET, even like game development. We have more, in fact, more certification programs than any other company in the world, right? Which we're pretty proud of. We're also really proud of this. We regularly are on every major best coding bootcamp list published each year, and we have been for over a decade. These lists started being made in 2014 when we started, and we were on the very first top coding bootcamp list, and we've been on there ever since as more and more have come out. Our average review rating across all online coding bootcamp review sites is 4.8 out of 5 stars. And this is from feedback. This is feedback from our students and our graduates. So we're really proud of that. This is what people who've gone through our program have to say about us, which I think is pretty awesome. Okay. So a couple quick questions. Why consider working in tech at all? One issue is just work-life balance. Tech in general has a really good work-life balance. I was talking with someone today, and I told my work in tech. He says, "Oh, you guys work a lot, don't you?" I'm like, no, we don't. Most tech jobs are 40 hours a week, and that's it. And that's how you go, right? But in addition, there's a lot of remote work possible in technology, which is a pretty cool thing, okay? Another really cool feature of technology is it's a very creative industry to work in, and you can take a lot of personal pride in your work. And you work with really bright people, and you solve difficult problems, and it feels great when you solve those problems. And finally, it's a stable industry. You're going to hear all kinds of things in the media. I've been watching it since I was 14 years old. There's always somebody in the media crying about how programmers as a career is dead, or this or that technological innovation is going to make them obsolete or whatever. It's all BS. We could talk about that for hours. But the fact is, over the long run, you start out in tech making a lot more than the national average, and it only goes up from there. It's actually pretty cool. Okay. What are the barriers to entry, though? Like, let's talk about boot camps in particular, because there's 3 routes into coding. There's 3 routes into tech: self-taught, boot camps, or college. That's really it. That's how you get into tech, right? So we know boot camps really well. And let's talk honestly about some of the barriers to entry. The first thing you have to think about is money. It costs thousands of dollars to go through a boot camp. Now, what we've done to make that a lot more affordable and approachable for people is we have, first of all, really big upfront discounts if you can pay upfront. And if you do need to finance it, then we've got different financing options for people with all sorts of credit. But the big takeaway for me is this: I truly believe that getting through a tech academy bootcamp is really an investment in yourself. You're giving yourself a set of skills that will serve you in good stead for the rest of your life. And we do it very, very effectively. Another barrier to getting through a bootcamp really is the time factor. And there's no way to get around this. There's a lot to learn in a limited amount of time to really make it worth your while, right? Some boot camps handle this by making their training work in what they call cohorts. One group of students all start on the same day, and they move through the program all at the same pace. Often, they even make you come into the building wherever they physically are, right? Well, one big thing on that, people don't learn at the same pace. People learn at their own pace. Our programs are self-paced, and they're fully online, so you don't have to come into a campus if you don't want to. You can come into our Portland campus. It's pretty cool. But finally, one other big barrier, and this is one I think it's just personally very important to me, is you do have to have at least some technical interest or aptitude. But very often I hear from people that are thinking about getting into tech or were at one time, and they feel like it's over their head or it's too complex or whatever. And a lot of this stems from the fact that many educational materials for technology have a fundamental flaw. They can make you feel really stupid, but it's not you, it's the material. And it stems from the fact that lots of people forget what it was like to be a newbie. And they create training material that assumes too much prior knowledge on the part of the student. We don't do that. With our programs, you don't have to have any prior technology or coding experience. They're for complete new people. You don't have to be a nerd to get through our programs. You are going to have to be a nerd to put up with the stupid jokes that I say during our curriculum videos, but there's no getting away from that. And if you're not willing to acknowledge that The Princess Bride is the best movie in the history of the world, I don't know what to tell you. That's on you. And yes, I do talk about that in our videos. So I've got a couple of questions for you. Are you in a dead-end job? And I don't mean that like in a real derogatory way, but I mean that when you consider like, what does your life look like 5 years from now, 10 years from now? When you look at the industry you're in right now, and what career progression really looks like for that industry if you do a really good job. Is it really going to be where you want to be? Is it going to meet your needs? Is there an income cap, right? Or maybe you're unemployed, right? Or maybe it's really important you spend a lot more time with your loved ones. They want remote work. The question is it time for a career change? And if it is, the Tech Academy is the answer. That bridge you see in our logo is there on purpose. We tried to put together the bridge into technology. You walk across that bridge and anybody can walk into a tech career, right? At this point, we have over 10 years of experience in becoming career change experts. We have thousands of graduates. On average, our graduates make $60,000 a year, $30 an hour, right? And we're just quite good at it. It's what we concentrate on and what we care about, right? Now, if this is of interest to you, then in this month of September, we've decided to continue a pilot program we had last month, which is that if you decide to enroll and you enroll this month, then first of all, if you can pay up front, we're going to increase our tuition discount to 50%. You get half off of whatever bootcamp you choose if you pay up front. Also, if you're in America and you need a laptop to do your training, we'll ship you a refurbished laptop at no charge, and it's yours to keep, right? Just to be able to get through your program and get started in tech. The other thing that is a September only thing is there's no sales tax. Now, it gets paid. We pay it for you. But no matter where you are, we'll take care of the sales tax. The other thing we do in September is we'll send you physical copies of our coding books and our technology basics dictionary, which is really valuable. One of the hardest things about breaking into tech is all these words that are thrown around. And usually they're thrown around with really poor definitions. So Jack Stanley and I, my co-founder, we took this is built over 18 months and it's since been revised. There's thousands of technology definitions in simple, clear language. So you don't get hung up on the definitions because they're so important. The other thing we'll send you, and this is really big, is we have a book we call our career planning guide. It lays out exactly how to navigate the first 3 years of your technology career. What do you do and concentrate on in the first 6 months, the first 18 months, the first 36 months to set yourself up well for a great long-term career? It's advice and guidance that I wish I'd had. And so we put everything we've learned in all of our decades in technology into this book, and you get a free copy of that. Also, if you enroll in September, you'll get 3 months of free access to my favorite service we deliver, which is the Tech Academy Accelerator. This is a really low-cost subscription offer that gives you access to over 100 free online training videos and 100 free online mini courses. But most importantly, you get access to our weekly workshops, and they are a blast. These are not like a one-way flow, kind of have to listen to Erik talk. This is a conversation back and forth where each week we dive into some technology concept really deep. We get our hands dirty, we build things, we break things. It's designed to accelerate your career by really showing you what it's like to do the job by actually building things. They're a blast. And finally, for September enrollees, you'll get unlimited job placement assistance. And that's a real big deal. Our job placement personnel have been, they're on a team that's gotten over, thousands of people into tech. And when you're done with the program and you're out there and you're on the market and you're trying to get hired, one of the most important things is to have access to people that really know what that's like and know how to get you through any of the obstacles, barriers, flubs, like interviews that went bad, whatever. You got access to those personnel for as long as it takes for you to get that first job, which is a huge benefit. So if this is of interest to you, then go to this link right here, learncodeanywhere.com/Erik, and there'll be a simple form to fill out. After that form, and you don't have to do the later steps right now, but once you fill it out, there's a bunch of steps that explain the school. There's articles and videos, and they go over how do we train people? What's the curriculum look like? What do you learn in what order? Why is it in that order? What's the experience like? How do I interact with my instructors? All this stuff gets answered to your full satisfaction before you make a decision. But I highly recommend, if there's any interest at all, fill out the form and start studying to your heart's content and learn as much as you can about the Tech Academy. Because if it's the right fit for you, man, it's a life changer. It's a life changer. Technology is a phenomenal industry to work in. I'd say that after decades in it. I love it. All right, so I'll give a moment there for anybody who wants to fill that form out, and then we'll move on. And sit tight, your free gift is coming in just a moment. I do want to make a quick mention of our referral program. For years, our top source of enrollment has been referrals from our students and graduates because they love us and they tell their friends about us, right? But that's not restricted just to people who are students and graduates. Anyone can refer someone, and we keep track of that. So in a moment here, we're going to give you an email address where you'll be able to get your free gift. And if you want to include any data about someone you think we should be talking to, a referral, we keep track of that. And if they end up enrolling and pay tuition, we'll immediately send you a check of 5% of their tuition payment, just because you will have done them a phenomenal thing, a gift, and we want to reward you for it. I mentioned books. We published 6 books and a dictionary, including 3 Learn Coding Basics books, a book for kids and young adults to learn how to code, a project management handbook, the Technology Basics Dictionary, and You Are Not Stupid, which is a phenomenal book. It removes all mystery from computers and technology. Both you and especially your loved ones should read it so that you don't end up becoming the tech support person for your whole family. Not that that's ever happened. So here's our gift for you tonight. I want to give you something where if you really want to dive into coding, this is a phenomenal introduction to it. Okay, this is also the book we give out when we do our free Python coding classes. And Jack and I, we worked on this for a long time, and it's really, really quite good. Okay, we'll send a physical book to your house, but you have to give us your mailing address. Every once in a while, we have people that say, "Yes, Eric, give me that book," but they don't give us an address. So, in chat, you'll see books@learncodinganywhere.com. Send us off an email and say, "Hey, I was on the class with Eric. He said I could get a free Python book. Here's my mailing address," and we'll send it out to you. You can also put in that email any referrals you have. And again, we do keep track of those. You can also throw in there any further questions that I didn't get to. Those always get passed on to me. I love answering them, and you will get an answer from me. I'll give a second for anybody to grab that email address and fire off an email if they want a copy of the book. By the way, unfortunately, this is for America only. If you're joining us from overseas, we can't send it overseas. But you can get a Kindle version of the book for like $2 or something like that. I do also want to let you know about our link tree. If you're not familiar with Linktree, it's a way to put all of your links on one page. It's really what it is, right? So that link is in chat. Go ahead and grab that, and you'll see links to our free educational YouTube video list, which is great. And this recording will be on that YouTube list within 24 hours. Links to all of our books, our dictionary, links to our upcoming classes, and all of our social media. So please follow us on social media. Go on there and look for our next class, right? Our free classes. And we'd love to see you at future classes. And that brings us to the end of our workshop today. I want to tell you how much I honestly appreciate you taking the time to do this. It's a Friday night. You could be doing anything, but instead you can be out like partying, having dinner or whatever. But you chose to invest in yourself and find out more about technology. And I just love people that are interested in tech. So if there's any way we can ever help you, let me know. Meanwhile, there's that same link to apply to learn more, right? And if you even fill this out in September, when you finally figure it out and pick your bootcamp and enroll, all those September bonuses are there for you. 50% off for upfront tuition, a copy of our coding books and the dictionary sent right to your house, unlimited job placement assistance, our career planning guide. We take care of the sales tax. Like, we really want to make technology accessible for you and be your route into tech. So that's what I have for you. I hope you enjoyed it. I hope it was helpful. Please join us at future classes, and I'd love to see you inside the Tech Academy. Thanks so much for attending. I really appreciate it.